Have you ever kind of wondered how your computer knows the difference between, say, a number and a word? Well, there's this quiet but really powerful concept working behind the scenes. It's called type checking, and today we're going to gently pull back the curtain on it.
I mean, we've all been there, right? You write a piece of code, it looks perfectly logical to you, you hit run, and it just breaks. Or maybe even worse, you get this really strange error message that just doesn't make any sense at first. It's a pretty universal feeling for anyone who's ever tried to write code.
And a lot of the time, the problem is something just like this. We're asking the computer to do something that, well, it just doesn't compute. Adding a number to a word? What would that even look like? It's kind of like asking, hey, what's the color blue plus the sound of a bell? It just doesn't have an answer.
So how do we stop ourselves from making these kinds of logical mix-ups? Well, luckily programming languages have this sort of built-in helper. You can think of it like an automatic proofreader that's constantly just checking your work for these exact kinds of errors, long before they can cause any real problems. And this proofreading process, it has a name, type checking. At its very core, it's just a technique that's designed to catch inconsistencies. You know, especially when you try to do something like add or multiply with the wrong type of data. And you know, this isn't just some random rule somebody made up. It's a true cornerstone of computer science. It's detailed in foundational textbooks like this one, which generations of programmers affectionately call the Dragon Book. It's one of those core ideas that makes all the reliable software we use every single day even possible.
Okay, so to really wrap our heads around this, let's use a super simple analogy. Let's just forget about code for a minute and think about something much simpler: shapes and holes. So just imagine that every single piece of data in your program has its own unique shape. Let's say a number, like the number 5, is a nice, solid, predictable square.
And then a piece of text, like the word hello, is a totally different shape. Let's call that one a circle. They're both really useful, for sure, but they are fundamentally different things.
So the obvious question is, what happens in the real world when you try to jam a square peg into a round hole?
Yeah, it doesn't work. The shapes don't match up. And in the world of programming, this exact mismatch is what we call a type error. It's literally the language telling you, hey, this square thing, it's not going to fit into this round spot.
And that's really the whole idea. All type checking is doing is making sure that the shapes of your data fit into the shapes of the operations you're trying to do. It's really just a simple matching game to keep everything running the way it should.
Now, this little check can happen at 2 different times. With static checking, it's like having a spell checker in your word processor. It flags typos as you're writing before you even try to run the code. Then there's dynamic checking, which is more like a proofreader who only looks at your document after it's all finished, catching errors while the program is actually running. Each way has its own pros and cons, and it's a really big design choice for any programming language.
So why go through all this trouble? Why does the language care so much about matching up these shapes? Well, it's all about providing a safety net for you, the person writing the code.
And this safety net is so important. It catches all these little bugs really early, which prevents those super frustrating, unexpected crashes later on. It also kind of forces us to be really clear about the shapes of our data, which in turn makes the code way easier for other people and our future selves to understand. And really, this simple concept is what allows us to build the huge, complex, and reliable software that pretty much powers our world.
So I want to end by maybe reframing how we think about these kinds of errors. You know that initial feeling of frustration when your code just stops working? Let's try and turn that into something a bit more positive. So here's the big takeaway. A type error is not a failure. It's not a dead end. It's actually a form of communication. Just think of it like your programming language is gently tapping you on the shoulder and giving you helpful directions to fix a problem it already found for you.
So really, the next time you see one of those type mismatch messages, just take a calm breath. It's not a criticism, it's just a quiet little confirmation that your personal proofreader is on the job and it's looking out for you. Your language totally has your back.
Happy, safe coding.